Hey guys, I've decided to re-record this because the internet connection wasn't great and it was really choppy when I was rewatching it. So I just wanted to help you out by doing these examples all over again on from Google Meet. So for the first question, you want to state which ones are exponential and then explain why or why not. Okay, so for it to be exponential, you're going to have in the simplest form, you're going to have a base, meaning a number, and then to the power of x. So, of course, that's the most basic kind of exponential, but you can have something like 5 to the power of x plus 2. So as long as that variable is in the power spot. You can also have numbers around it, like 5. Now, what you're trying to do to confirm that something is exponential is if you graph it, it should look like that where it's increasing very quickly, or it should look like that where it's decreasing very quickly. So that's kind of the fastest way to figure out if something is exponential, is graph it and see what it looks like. So that's for question number 1. Question number 2, they're asking you to state a few things about this. So we're going to do A and D. Okay, so for the first one, the value of A is 4, and for the second one, the value of A is 10. So that's the coefficient that comes in front of your base. Your B is your base, so that's the value that comes directly or is attached to that variable or that exponent x. So 2 is your B value, and here your B value is 1/2. Then you want to graph it, so you would use your graphing calculator. Okay, so in y1 or y2, I'm going to show you what I'm doing. So y1, you're going to go, in our case, we have 4 to the times 2 to the power. So the power button is right underneath it, underneath your clear button. So right underneath, you're going to put power and then the variable x. You're going to use the standard window, so -10, +10, -10, +10, and the scale should be at 1. Okay, so graph it and it should look like that. So what you're going to do is sketch that. And this one, same thing. You're going to sketch that. It should be 10 in brackets 1/2 to the power of x. So it should look like this. So what you want to clearly show is that it doesn't touch the x-axis. It goes very close to it, but doesn't actually go through the x-axis or touch it. So that would be the graph of it. The domain would be x such that x is an element of the real numbers for both, because they do extend forever left and forever right. And then your range, y such that y is greater than 0 YER, because your graph will be above the x-axis, but it won't actually touch your x-axis. And it'll be the same for both. Y is greater than 0 YER. And the coordinates of your intercepts, there are no x-intercepts. So there's going to be none for both. So that's going to be the same for both the first one and the second question. So there's no x-intercepts. And y-intercepts, it's going to be the same as your A, same as a value. So in the first case, you're going to say that your y-intercept, the coordinates, would be 0 and 4. And for the second one, the coordinates would be 0 and 10. Okay, so that's the A values. Now, to do that with your graphing calculator, to confirm that, you can just press trace 0, enter. So I'm going to do it a different way because my calculator doesn't really allow me to do it that way, but you're going to do trace 0, enter. And that should give you the y is 10 for the second one that we did. Okay, so those are the coordinates of the intercepts. So that one's similar to question number 2 in your assignment. Question number 3 in your assignment, you're going to start with the question. We're going to do this one here. So for each one, you're trying to get these two numbers, 9 and 27, to have the same base. So I'm picking you're either going to have the base of 2, 3, 5 is common, so those are the common bases that you would use. In this case, I'm going to use 3 because 3 to the power of 2 can replace 9, and 3 to the power of 3 can replace 27. You need them both to be the same numbers. So there's no other number that would work for both 9 and 27, so it has to be 3. And then the powers that were originally there should still stay there. Next, you're going to distribute that power that you have to the existing power that you started with. So it's going to be 3 to the power of 2 times 1 is 2, minus 2x, because 2 times negative x. And then on the other side, you have 3 to the power of 3x plus 6, because 3 needs to multiply with the x and the 2. Once you have the same bases on each side, they cancel each other off, leaving you with the powers equaling each other. So you're going to isolate for x by moving the x to the other side. So that's going to be 5x plus 6. Then you're going to subtract 6 on both sides, and that gives you negative 4 equals 5x. Then divide by 5 on both sides. X equals negative 4 over 5, which in your calculator, x is equal to negative 0.8. So that's your solution algebraically. So this is the algebraic way. Now we're going to go graphically. Graphically is where you put y1 is the left side of your equation. So you go back to the original question. And your y2 is the right side of your equation. Now, in your calculator, you should always put brackets around your powers to keep them together. So that's what your y1 and y2 should look like, the left side and the right side. Left side, right side. Now, we want to figure out the coordinates of the intersection, so we're going to graph this with our calculators. So it should be 1 minus x. And when I use the standard window, I don't see the intersection because I have to go higher. So I'm going to have to change my max. Instead of going up to 10, let's go up to 100, because then I can see that the intersection is around there. So then I press second trace number 5. And then you're going to go as close to the intersection as possible and press enter 3 times. So you should get that these are the coordinates. Negative 0.8. And if you go back, mine are 52.2. And that means the solution is always the x coordinate. So x equals negative 0.8, and it matches. If you guys look, your algebraic answer should match your graphical solution. And that's how you would do the first, those 3 kind of sections, those 3 questions for question number 3 in your assignment. So what you want to do is work on questions 1, 2, 3, and then next week you're going to learn the stuff for questions 4 and 5, and then it'll be due at the end of next week. Okay, so thank you guys.